Assalamu alaikum. My name is Malik Hassan and I am doing electronics engineering degree from Air University Islamabad campus. Currently, I am enrolled in second semester. Today, we will talk about how a computer works and its flowcharts. Uh, the currently enrolled of this subject is computer programming, and we will discuss the use of computer in our daily lives. So let's proceed towards the topic. So let's talk about what is a computer. Basically, a computer is an electronic device designed to process information systematically and efficiently. At its core, a computer follows a simple but powerful cycle. It accepts input from users or other systems, processes that data according to the programmed instructions, and produces meaningful output. Unlike calculators, as we see, or simple electronic device, computers are programmable and versatile. They can execute complex sequences of operations, store vast amount of information, and perform millions of calculations per second. This makes computer flexible, essential tool in engineering, science, and everyday life. So basically, modern computers execute billions of instructions per second, making them for solving complex engineering problems. Computers are essential part of our life, and it is basically used in daily life. So let's talk about the categories of computer. So basically, computer come in various sizes and capabilities, each designed for specific applications and workloads. Understanding these categories help engineers select the right computing platform for their projects. So first we talk about the mainframe computers, large powerful systems used by corporation and government agencies and sectors for processing massive datasets. They handle thousands of simultaneous users and are known for reliability and security. Banks, airlines, and insurance companies rely on mainframe for critical operations. In the second, we talk about the mid-sized computer. They are also called mini-computers or servers. These systems bridge the gap between mainframes and personal computers. They support multiple users simultaneously and are commonly found in universities, research labs, and medium-sized business for departmental computing needs. In the third, we talk about the microcomputers. As we know that the personal computers including desktops, laptops, tablets and the smartphones we use, these are the most common type designed for individual users. Despite their small size, modern microcomputers possesses remarkable processing power suitable for engineering simulations like CAD work and programming. So let's talk about the computer system components. So first of all, we talk about the hardware of the computer, the physical part you can touch basically, like chips, cable, and screens, or we can say that mouse and keyboard. After that, we talk about the software, the instructions that basically we tell the hardware what to do. It is basically the instructions which are given to the computer, which tell the hardware that what to do. After that, the CPU, which is the main part of the computer. So basically CPU is the brain of the computer which processes instructions and perform tasks. And the important part which is after that storage. So storage includes main memory, which is known to be as RAM, for quick tasks, and secondary storage like hard drives, which are used in daily life for long time saving of the data. After that, we talk about the I/O devices. So what are the I/O devices? These are the tools like sensors and screens that tell humans and machine talk to each other. So these are the basic computer system components we have discussed. So let's talk about the central processing unit, which is known to be as CPU in simple words. So you have probably heard that the brain of the computer and that a perfect description, just like your brain that tells your hand to move or your eyes to blink. The CPU executes every instructions and coordinates everything your computer does. Inside the tiny chip, there are billions of transistors working together. First up, we have the control unit or CU. Think of the CU as a traffic cop or a conductor. If it does not do the math itself, instead it fetches instructions from the memory, figure out what they mean, and tells the rest of the computer exactly what to do. After that, the arithmetic logic unit ALU. Next is the arithmetic logic unit. This is the computer's calculator. If you are playing a game or editing a photo, the ALU is doing the heavy lifting, handling all the addition, subtraction, and logical decisions like checking if one number is bigger than another. After that, it comes the program counter, which is known to be as PC. Imagine you are following a recipe. The program counter is like your finger pointing to the next line of the instructions. It keeps track of the memory address of for the next task, making sure that the computer stays in the right sequence and do not skip a beat. After that, the instruction register IR. While a program counter points the next step, the instruction register holds the current instruction being worked on. It holds the pieces of data steady so that the CPU can decode it and processes it instantly. After the whole conclusion of this slide, we can say that the CPU, it consists of four small parts working in this perfect science to make the digital world happen. So that's the quick overview of the CPU, which is known to be a central processing unit. So let's talk about the hierarchy of the memory of the computer. So basically computer memory is organized in a hierarchy to balance speed and cost. This is the secret to system performance. Primary memory is fast but expensive, while secondary storage is slower but much cheaper. So basically modern SSDs are the game changers here, offering speed that approaches RAM with the huge capacity of a hard drive. So primary, let's talk about the primary memory. RAM or random access memory is volatile. It only works while the power is on. It's where your active programs live. ROM or read-only memory is non-volatile. It is permanent and stores the essential firmware that starts your PC. So let's talk about the secondary memory. For long-term storage, we use HDDs for massive capacity at a low cost, or SSDs for high performance speed for everything else. We have removable media like USB drives and CDs for backups or on the go. So in today's world, we basically use the USB drives instead of CDs, which makes the storage more easier and transfers the data more fastly. So in this slide, we will talk about the input and output devices. Devices act as an interface between humans and computers, allowing the data entry and result presentation. So in the first, we will talk about the keyboard. This is the primary text input device, featured over 104 keys for typing uh, and giving command, code, and data. It is essential for programming and system controls. After that, we will talk about the mouse, the pointing device used to navigate graphical interfaces. It is use optical or laser sensor to track movement and translate it to your cursor position. After the scanner, this device converts physical documents and images into digital format using optical sensors. It is particularly useful for digitalizing drawings and schematics. After that, talk about the monitor, the visual output device that displays text, graphs, and video. Modern screens use LCDs or LED technology with resolution reaching 4K and beyond. After that, we talk about the printers. This produces physical copies of digital documents. Lasers printers offer precision for technical drawings, while inkjet provide color versatility. versatility. After that, we talk about the speakers, audio output devices that convert digital sound signals into sound waves. These are important for alerts, multimedia, and accessibility features. So after that, we will talk about the software and programming languages. So what is basically the core concept of it? So basically, software serves as the life of hardware, turning electronic circuits into tools that solve problems. So we talk about the software layers. It exists in multiple layers, ranging from low-level machine coding up to high-level applications. After that, the system software, it includes operating systems like Windows, Linux, and Mac OS, along with utilities that manage hardware and provide the user interface. After that, the application software, these are the programs built for specific tasks such as word processor, web browsing, and engineering tools like CAD. After that, we'll talk about the binary language, which are the zeros and one. The language of zeros and one that represent electrical states on and off. This is only thing computer truly understand. This is basically the language of the computer which it understand easily. After that, the high level languages, human readable languages like Python, Java, C++ that use compilers to translate code back into machine readable binary. So this is the software and programming languages overview. So in this slide we will talk about the algorithms and flowcharts. So basically, the before writing and code, engineers must plan their logic systematically. Algorithms and flowcharts are the essential tools used for designing, communicating, and debugging program logic. So let's talk about what is algorithm. This is a step-by-step procedure for solving a problem to be a successful, an algorithm must be finite. It must eventually end. Definite. Each step is clearly defined in it and effective. It produces the correct result. What is pseudo code? This is an informal high-level description of logic using plain language mixed with programming terms. It bridges the gap between low human think and how code is actually written. Flowchart symbols. We use standard shapes to represent different actions. Oval for start, stop, rectangle for processes, parallelogram for input and output, and diamonds for decisions. Why we use flowchart? This question may arise in your mind. So the answer is that they provide visual clarity for complex logic and make it much easier to spot errors and missing steps. They also act as a universal symbol for team communication and serve as permanent records for program decision. So putting all together a complete flowchart is given in front of you. So what basically the flowchart shows, this flowchart shows that the heartbeat of every program from a simple calculator to a complex robot. The flowchart, every software application follows a simple basic pattern which is now shown in front of you. First the start, after that input, process, output, and then at the end stop. So the start and stop is indicated by the ovals. These shapes mark the beginning and end of a program, defining its boundaries. Input and output are denoted by parallelograms. This represents data entering the system like from a sensor or keyboard or leaving it like a display or monitor motor moving. Processing is denoted by rectangles. This is where the math happens, calculations, data manipulations and transformations. Key takeaways. Mastering these basic architecture, memory, input and output and algorithms is the foundation of engineering, robotics and automation. So this is all about how computer works and its component, and I have also explained the flowchart, that how the flowchart is made and what how these are indicates the start stop with which shapes. So that's all about how the computer works. So thank you for watching. Allah Hafiz.